Okay, so 1 second. Right, obviously, download development libraries, Visual C++. So pretty much, I haven't prepared anything yet. I'm just going to kind of figure this out as I go along. I mean, obviously, I have created applications like this before, but not recently. Like the game I made, the other games using LibSDL. Actually, I can't remember. One of them, the Dave Newcomb game uses the older LibSDL 1.2, but it's so long ago that I don't remember. You know, so I pretty much just want to start sort of clean and from scratch on some other new project. So we download development libraries for Visual Studio. Personal SDL2. So the first thing we need to do is set up. Actually, I'm not sure. Let me dig into some. Just want to check what type of. So I think we're going to just say file new project, right? Pretty sure that's Visual C++. I'm not sure if we're going to say an empty project or if we must say a Win32 project, I guess, maybe, or a console application. I don't know. So there's some things I'm not sure of. I'm just gonna let me have a look at if I can now I'm literally just reading someone else's tutorial. That is, so I've downloaded the library. Create a new project. According to this administrator, empty project. Okay. So let's try this. Let's create a new empty project. C++. Empty project. Where are we gonna put it? Source. Build, I guess. Let's see what it does. Okay, that looks neat enough. Now we need to set up and make sure. I see I already have a copy of SDL2 floating around here, but it's probably an older one. Yeah, okay, I've got some older version there floating around. So what I want to do, I guess, is unzip this into some new folder. Just third party. Okay. SDL. So I've created a new folder, cd third party SDL, and I've unzipped the download, the development libraries, Windows, Visual C++. I've unzipped this now into that folder. I've made one small change. In the zip file it says 2.0.5. I've just made that SDL. Why? Because so that I don't have to, if I download a new version in future, I don't have to update the path in my system properties. Now we want to add these paths in Visual Studio. The place we're going to do that, go to the View menu, not property pages, Properties window, and that opens a little window down here on the, whatever you call the sidebar thing, Property Manager. Okay, and I suppose there's a few different places I could put these, but I set up in a central place on Microsoft.cpp.132.user, which are the kind of global settings. We right click on these, select them, control click, right click, properties. Okay. go to VC++ directories. Now we need to, there's two sets of directories we need to add. The include directories that for the header files, and the library directories for the lib. Now I have to be careful here because I've already got the old SDL2 as well as SDL1 in the path. So I must either delete those, which I don't want to do necessarily. Oh, that's SDL2 image, not SDL2. What is this? SDL2. Oh, that's not being used. I think I've used it. I should probably just delete it because it's old. Anyway, what I want to do is add I'm not 100% sure if I should be including like the actual include folder. Probably. Yeah, I think like so. So I'm going to add this and then just move this up to the top. What happened there? I think I must use this button here. I thought I could drag it. Apparently not. Okay. That's probably a little bit fun for you guys to read, but so that's the SDL include path. Now we want to add the library path lib for the .lib. Okay. I'm in the wrong folder. I just want to check I added the correct one. Nope. I added the wrong one. That's the old one. Okay. That should be better. Right. Now there's two folders here, x86 and x64. x64 is presumably if you want to build a 64-bit application, which I'm not going to do. I'm just going to build a plain old plain old 32-bit application. So I guess we're going to just add this to our library directories and move it up. And say OK. So I close this to make sure. Alright. Let me close that. The last one saves the settings. So yeah, I'm creating a brand new Hello World application with LibSDL 2. And I have not prepared anything, so I'm just fly by way. I'm just figuring this out as I go along again. I have done this sort of thing before, obviously, but not recently, so my memory is a bit fuzzy. Okay, Solution Explorer. We have no source files and no header files. Okay. So we're going to create a folder for our source. And to start with, I don't understand Russian, but and I'm literally copying someone else's tutorial yet. So we add the paths, I've done that. Setting the library path, I've done that. Yes, add the library dependencies. So this, we have to go to our, we can go here to Solution Explorer, right click on Hello World there and say Properties. And then we go to Linker Input. Okay. And additional dependencies. What? Well, where is the? Okay. So we want to add. Yes. We want to add these SDL2.lib and SDL2 main.lib. Now I presume if we add SDL2 main.lib that we get a main function defined by the LibSDL libraries. Because every application has to have a main function. But the main function can be defined by a library and then we don't have to define it. And I think that's what's happening if we link SDL2 main. Subsystem. Linker system, subsystem. So to see the console, I don't really want console because I think I'm going to select Windows. Right. Because I don't want that annoying console. I might want to turn this into a game or something. Like, depending how far I get, I may want to make a new game or something. So this is not my tutorial, by the way. I'm copying some other guy's tutorial, but I'm dropping a link. Yeah, if anyone is interested. This, that's, I don't know what's this, obviously. I'm just following someone else's tutorial to but like really quickly. Okay. The last thing we'll need to do is whatever application we build isn't going to run because it's not going to find the DLLs. There's two things we can do. We can either copy the DLLs into the application path. So it actually compiled. I said build configuration manager. I switched to the release because I don't like working in debug mode. And I pressed F7 here to build solution. I don't even have any source code, but it built a, what did it build exactly? It will release. I don't see any executable or anything. It says built, but what's the build output? I'm not bit rusty. Cancel what you do. Release. I think we need to go linker general output file, target extension. We should have an executable somewhere. Okay. Let's see. Programmable links. Maybe we do need to add main. Let me just see if there's any steps I skipped here. Adding the library dependencies. Unless I need to set console instead of Windows. But I don't want to do that, like I said. Programming is simple sanity check. Right, I'm going to copy and paste this. Touch. So I go into my folder, just using a file manager title commander to create a blank CPP file. Let me say add existing item. Right. And we copy and paste this guy's, or this person. Oh, actually, yeah, I use a mic sometimes. You can hear me? Yeah, I assume you can hear me. I hope so, because I've been talking a lot. Yeah, okay. Right. Fatal error. Entry point must be defined. Why do we get that? I don't know. We're going to Google this and find out. So this is not a neat tutorial where I've prepared very well, so everything is going to go right. This is more like a real world thing where you follow someone's tutorial and then you get a link error and then you have to figure out why. Okay. Blah 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 blah. Anyway, what does this mean? I think it's got something to do with main and the fact that I have set the system to win. Oh, the system's not even set. Maybe that's got something to do with it. Yeah, there we go. Now we got an unresolved win main. So we probably need to. Yes, that's right. Okay, we're creating a Windows application. So instead of a main, we need a win main. Of course, this is coming back to me. So if we were creating a console application, then this would probably work. It would probably not give this error unresolved win main, but I don't want to create a console application because it's going to have this console box. That's not wrong, but it's just going to have this silly console box, and you can't use that. You know, if you want to make a real thing that you're going to distribute to people. So I think we need a basic win main. I'm going to go check out the source code of Dave Newcomb, which of course I wrote, but I did this so long ago. And also, this is SDL 1.2, plus it was done on an earlier version of Visual Studio 6 probably, and then right, so what am I looking for? What was it here? Win main. I want to see if I have a win main function. Yes, we have a very simple stub win main that just calls the main. Okay, pretty straightforward, I guess. Okay. Fix me. The Intel compiler thinks that you're going to do this. That's I wrote long ago. I don't think that's relevant. Okay, so we're going to have our main function, and then we're going to define now, if we wanted to have a cross-platform application, then I would do something like this. Let me do whatever I do. I want it to be cross-platform. So we would do something like this. /ftf win32 and so all the Windows-specific stuff include windows.h and our win main function. So on Windows, the entry point of the application is the win main function on Win32, while on non-Windows it's the main function. So this if we're on Windows, we define a simple win main function. We don't have to extend it because it's just above us. And why is that Win32 not defined? Probably have to define it. Well, I thought it's defined already. C++. Okay, wait, maybe we should be looking for good question. I guess it's not automatically defined. Let's see what I did in this application. I defined Win32. Okay. Oh, that's simple enough. So let's do the same. So we go to our project. In the Solution Explorer, we right click on the project, Properties, C++, preprocessor, and in preprocessor definitions, we add Win32, right? And we should do that for debug mode also, because these are defined separately for both release and debug mode. Okay, now we try build, and okay, right, so I hit F7, compiled, and it says it generated a hello world executable, which we're going to try run. Right, so there we are. Okay, it's not quite hello world yet, but okay, that didn't take very long. So what are we going to do? No, we're not there yet. We don't have a hello world yet. We don't even have anything interesting yet. So this stuff is obviously, if we're going to be cross-platform like Linux or Mac, then it'll just have the normal main function as the entry point. Otherwise, on Windows, we define a win main which calls the main function. So straightforward. Obviously, this SDL init. Oh well, not SDL init, but there's a lot going on here that. Anyway, what we want to do. Oh yeah, now if we say start debugging or whatever, start F5 to run, we get, and this is normal, we get an error because, so yeah, it has to find when it compiles, it has to find the header files. When it links, it has to find the libs, and when it runs, it has to find the DLLs. Now there's a couple of ways. We can either copy the DLLs around, which is gross, or we could do something else, which is also gross, and that's in the whichever way we do it, it's a bit gross. Okay, we could add the paths for the what we're going to do is, right, we go to our right Solution Explorer on the right bar again, right click on Hello World, say Properties, and we look for debugging, and under debugging we're going to have environment. Okay, so what we're going to do, we're going to add a line in environment that looks like this. Path equals C, and then we're going to add the path to the DLLs, which I'm going to get because that's not correct, and a semicolon, and then percentage path percentage. So that means that as it runs, as you run it out of Visual Studio, what it will do is it prefixes to the path environment variable temporarily the DLL folder, which there it is. That's what we unzipped earlier, so we can put that in there. Okay, so we went to project properties, debugging environment, path equals, and then the path to the DLLs, and then semicolon percentage path percentage. And then see if that runs. Boom, it ran. Now it ran and exited very quickly, which is correct. It doesn't do anything interesting, but if I put a breakpoint there, you'll see it's running and it's getting there. So I hit F9, I create a breakpoint, I press F5, and here we are. Call stack. See, here we are in win main, calling main. and all it does is call SDL init and then print again. What I quickly want to do is add that same line. So we go, now when remember we have to do this now for the debug and for the release. So we go build configuration manager and select release DL. Welcome. I don't know what that's about. That was our release. So we go build configuration manager and we select release. Okay. Or we could do it from, we'll again go Solution Explorer properties, debugging, environment, and that same line because that's, so now F7. Yes, we need to add the libs as well, SDL2.lib. So now we're just getting linker errors, and that's because we like we did with the debug. C++, not C++, linker input. Linker input we add these two for release mode build. And save all and build solution, and it builds hello world.exe in release mode. Run Control F5, and obviously we can't set breakpoints and so on into release mode. Well, generally speaking, there are ways to get it to do that, but not going to get into that now. Right, so now we have a very simple, the most basic possible LibSDL2 application. It does nothing, but it's the basic application, compiling and linking. We can now start adding some meat, some flesh. Right. I'm going to put the date in here, I guess. So now I want to actually do something like create a window and display something in it. So to create a window, we're gonna, so we need to do two things basically. The idea is we want to, so what we want to do here, we want to create a window. And since this is probably going to be a game, I'm going to call it game window. No, I'm just going to call it application window. Application window, but that's our game window. I'm going to make, I don't know what I'm doing yet, but I want to make a game, a new game. I don't know what it is yet. This is a totally new project. I just feel like creating something from scratch. So over here, do next, create game window. And then we need to create some sort of update and rendering loop. That will go, yeah. Okay. So I think I want to make some puzzle game or something, but I don't know yet. But it doesn't really matter. You know, the principles are the same. Whether you're making a 3D game, or whether you're making a 3D game or a 2D game or a fancy 2D action game or or something really simple and basic like a puzzle game. The basic principles are the same. Yeah, what we've done is exactly the same. And there might be a few minor differences in how you approach, the details once we get into the game update and rendering it. But we're going to try to do this generically, so this sort of framework, I could go in any direction from here. Anyway, so now Right, SDL. The SDL init function, you can specify which, SDL, let's go have a look, SDL init. SDL can handle different things for you, and SDL init, you tell it which parts you want to use, because, for performance and efficiency reasons and so on, like, if you don't want to use audio, then don't pass, you pass different flags depending on what you want to use. If you only want to use video and not audio, then don't pass audio, so that you have the most efficient possible subsystem initialization. I probably want to use timers. I do want to use video. I will want to use audio. So I don't know. I will use events. I don't know what no parachute means, but let's ignore it. Right. So I'm gonna pass here init everything. Okay. And I'm calling again somebody else's thing. Basically, we want to create a window, right? What was that thing? No, not that. Huh? I'm trying another new browser here, by the way. Pale Moon. So after SDL init, we want to call, what is that thing called? Now again, I'm copying this whole usher.io tutorial. Oh yeah, this is a bit different to. Right. SDL window. Sorry, I'm very attached to my naming conventions and so on. Right, so what I forgot to mention above is we've included SDL.h, and I see he's included iostream.h, but it's not clear to me why that's necessary. I'm just using the cout stuff, which I don't actually want to use. So I think I can take away iostream.h. Actually, why not use it? Why not? What's bad about it? I'm just old-fashioned. Like, I'll use printf and stuff like that. Help from me. I can try. I don't know what. Right. Okay, hold on. I'll check my messages. and resize this so that everything fits. Okay, so we're in Visual Studio. We've okay, so the iStream stuff, that's just for console logging for errors. I'm not going to worry about that right now. Right, so for SDL code window, hello world, but I'm going to take away the exclamation mark. SDL code window. I'm trying to check the documentation here. XY width height. I actually want to create it right at the top for reasons. You know, Dave Newcomb, this has irritated me for a long time. On Dave Newcomb, you don't have any control over the way the window, you don't have any direct control over the way the window starts. And, you know, it would often create the window partially off the bottom of the screen. And that's why I just want to make that 0. 0, okay, 640 by 480 sounds like something out of the 1990s. So, I don't know. Anyway, so that should create a window. I don't know if you, if I put a breakpoint here, it's actually created. You can see now, I'm running it, and it's created our hello world window. But what's going to happen is, it immediately calls SDL quit. So you can't actually see the window, it just exits the application before you even see the window. So now, we need, so that's the window title, that's the X and Y start position, that's the size of the window, which we're just going to hard code for now. It can somewhere be 0, 0. Let's error check. So now we need to create some sort of loop. See, there's an OpenGL window type. That would be interesting to play around with because I want to try play around with OpenGL sometime. But for now, I'm just going to create a normal window. These are the different window types. Borderless, resizable. See, now yeah, you might want to do different things like depending on what the type of game is. But SDL window shown is ignored. So then what does it exist? What is it? Okay. Right. We probably should call SDL destroy window. Yes, I mean not probably. Yeah. So we're gonna do cleanup over here. If pwin, which is the same as saying not equal to not equal to null, then SDL destroy window. It's probably going to do that for us, but we probably should clean up after ourselves, I think. Yeah, okay. And I like to, after destroying something like that, I like to set the variable to null. It keeps things sane. Like sometimes you'll have some code here that tries to dereference P1, and if it's null, it's just much easier to catch that bug. Okay, so that is our application cleanup. We should now move all of this into sub functions and stuff, but the important thing we need next is some sort of rendering and update loop. And this is actually I was going to grab somebody's somewhere. Oh, not this one. SDL. Oh, hang on, this has changed a bit. Alright, let me read this. Now I can create a renderer to draw the window using SDL code renderer. Okay, this is slightly different to what. Letting that match image. Drawing the texture. Wow, this is complex. There's a lot just to draw an image. Okay. Again, I'm just following someone else's tutorial, but that's not a bad tutorial. Okay, so we create a window, and now it seems we need to. Do you really need to create a render? Let's check. Tutorials. Here's somebody else's. It's a different one. Creating a first window. Create a SDL window. Right, so this looks much simpler. This means we don't necessarily need to do the code renderer stuff. I don't know, because this might be for the older version of. Like I said, I'm figuring this out as I go along. So, right. Copy. Let's see if this works. So now I'm copying some other guy's tutorial now, or some other person's tutorial. I don't know if it's a guy, probably. Screen surface equals SDL window gets surface. There's quite a lot going on here. I just want to see if this works. So that should do what? screen surface, width 800, height 600. Okay. This is very basic, but what it does is, right, that window we've created gets a SDL surface which we can use to do stuff like draw. I just want to quickly, that font is probably too tiny for you to read, but I just want to check if it's not, don't need to lock it. It's splitting white, so I don't know if it's actually working. I'm going to change this to, say, green, RGB. Yes, okay. So what it does, it's 12 seconds. Okay. It gets a SDL surface, which lets us do some drawing operations on the window. We don't have a loop yet. We don't have any sort of loop. Okay, that's going to happen later. So it seems like there's two different ways to go about this. I'm going to have to probably have to do a little more reading up myself. SDL surface, screen surface. So we get a SDL surface pointer from the window, which lets us work with a surface. If you look at some of the members of that, the width, height, pitch. The pitch is important. Oh, that depends. Yeah, if you're doing yeah, for some operations. Fill the surface white. SDL full rect. Screen surface. So should we have to destroy this or something? Clean up afterwards. I don't know. SDL update Windows surface. This works like a flip. So what's happening is, I think, if I'm understanding it correctly, okay, if you know nothing about game dev stuff, this is pretty basic, but one of the really basic principles of any sort of game or game type application is that of a back buffer. If you, right, we have a window. If we just draw directly to the window, whatever it is, if it's a 3D world or if it's a 2D game or whatever it is, if we literally just draw directly to the window, then that drawing process, it's not gonna look good to the user, because even though it happens really quickly, like on the order of milliseconds or microseconds for this to draw, or for a triangle to draw, or for a texture to draw, or for a sprite to be blittered, the user sees that, and it'll be like a weird flickery effect going on. So, and also there's a problem of, not a problem, but a separate problem of your monitor updates scan lines. Oh, sorry, yeah, I assume that's what's LibSDL 2. Yeah. New version. Yeah, it's a pretty old library, but it's it's stable and it's well. I don't know. It's not the fanciest library. It's relatively low level. I don't know. Most people who want to develop games today might not want to use it because it's popular to use higher level or applications with a lot more higher level functionality, like a Unity. I don't know. Not applications. I mean frameworks. But there's nothing wrong with it. It's decent, stable library. What I was saying about back buffers. Yeah, the other problem is there's a problem you get that back buffering helps solve called tearing. But the basic principle is that if you don't draw directly, do your game screen drawing to the actual surface, the window, directly to the window that's visible to the user. If you have a copy, basically a whole copy, a whole invisible frame that's usually on the graphics card but off screen, and you render to that. So you render to this invisible surface, and only once you've drawn your full frame and you're ready to let users see it, then you flip the contents of the back buffer to the front buffer that's visible. There's various variations on that scheme, but that's the basic principle. And this SDL, what I'm seeing here, it seems like SDL update window surface, okay, is basically flipping the back buffer to the front buffer. So the actual operation is performed on a back buffer. So if we were to do a number of operations, like draw a number of rectangles, none of that would be visible yet to the user until we call update window surface, and then the results of all those drawing operations become visible to the user all at once, as it flips from the back buffer to the front buffer. Yeah, I'm a little bit conservative, I guess, with software. I've been burnt a few times by switching to cool new libraries that are fancy and do a lot of things, and then a few years down the line, those libraries disappear, and then nobody uses them anymore, and they're gone. The developers who worked on them disappear. What happens? It's difficult to predict, though. I mean, it's you can't predict what's going to be stable easily. It's difficult to predict which horse to bet on, so to speak. Like the Dave Newcomb game. Oh yeah, let me not get into. Let me not get sidetracked. The surface. So draw some rectangles. Okay. It looks like there's two ways of doing things in LibSDL too. We can use these basic operations and call update window surface, or it seems like they have a thing called a renderer. Where was that? We shall render present SDL. I want to read a little bit more on this later. Destroy images in RAM. Oh, we don't want to do that. Ultimately, we don't want to use software rendering because it's slow. You can get away with it maybe for a really simple game like a puzzle game or something, software rendering, but ultimately we don't want to use software rendering. When you use a GPU to render textures and you store a texture on the GPU, which you should, you use, let me just make this bigger so you can read as well. Yeah, this is good advice. So we should actually be using render present. Right, so I'm going to change this. Just going to take a 2-minute break. Yeah, this is all good advice. Okay. You should always use hardware rendering. It's far more efficient. You can load an image as SDL texture using the SDL image library, which I'm probably going to add. So I want to move away from this way of doing things. I quickly want to I want to just create a loop of some sort. Yeah, so, and this is all the same in Dave Newcomb. These principles are the same. Okay, basically, what I said, you create a game update and rendering loop. I mean, right now, it literally draws a green rectangle to the screen, flips it from the back buffer to the front buffer, and then it waits. And SDL delay waits, and that's in milliseconds. So to wait 5 seconds, we call SDL delay with 5,000, and that will basically sit with our green 800 by 600 window for 5 seconds, and then it will literally close the window and quit. So in order to now we must be careful here. What we need to do is create a loop. And now we could do this while true. This is really horrible. While true, now we have a loop. Now it's just going to do that in a loop, right? That's the basic principle, but we need to be a little bit smarter about it. The first obvious problem with this is that it's going to be using a lot of CPU because it's sitting in a tight loop that doesn't delay anymore. hello world is using. Yeah. Well, I've got 8 threads, 4 cores on this machine, so that's using basically almost a full CPU, almost a full core, which is actually a lot. Okay, the more correct way to do this is we need to create what's called a core event loop, where yeah, maybe on the horizon, but not right now. Creating something exciting. I don't know what yet. Yeah. It's going to be quite a bit of work to update the game to LibSDL 2. So this, what I learned from this, I'll apply if I ever do that, if and when I ever update that to a newer LibSDL. But, so running, create a boolean running while running. Yeah, I feel like maybe making a puzzle game or something. Or I honestly don't even know. Kind of just. And now I just want to make a hello world. Okay. And then take it from there. So, okay. So what we need to do, this event-driven story, we have a, and this is also how our Win32 application works. We have a core event loop. So you literally just poll events, and events are things like keyboard input, timer events. If you have mouse input, all of these things are events. So we sit in a tight little loop. Not too tight, because we don't want the CPU to be overloaded at 100%. That's important. But we set in a little loop, a tight loop as possible. Polling events like keyboard events, mouse events. So this is where we're going to, using this, we're going to get events like, hopefully, keyboard events and mouse events, or whatever it is we want to use. And there's a special event in SDL application called the quit event, which is called when the user clicks on the window, the X in the top right in Windows. When the user clicks on that, there's a special event that we also will receive called, I think it's called SDL quit or something like that, which will give the user some ability to close the application. So there's lots of different types of events. But we have a core event loop that just polls events, and then we look at the type of event. Is it a mouse event? Then do this with it. Is it a keyboard event? Then do that with it. If it's a quit event, then do that with it. So this is our game. The what? Just copying from that film. Yeah, so now I'm copying this lazyfoo.net tutorial. So yeah, while application is running, it's a nice comment. So there may be, within one update loop, there may be a bunch of events, like a keyboard event and a mouse event, and a timer event or a quit event. So within the loop, we're gonna poll for events. Okay. And we poll for events in a loop. We have a while loop while we have events to process them. And if we okay. So we call SDL poll event, which fills in the event structure if there's an event available, and it returns non-zero if there are further events to be processed on the event queue available. So while we have events, pull them off, and then we need to do something over the events, like the keyboard events or whatever the hell they are. I'm not exactly sure architecturally how this is going to be translated yet into a game. In Dave Newcomb, we have, oh yeah, and I don't know if that's the right way to go. I don't know if I like it or not. In Dave Newcomb, each thing sort of has its own, each part of the game, like the main menu has its own loop, and then from a main menu it calls the game. Why are we in wide mode? That again. Okay. And then if you go into the in-game menu, for example, the in-game menu has its own event loop. If you press instructions, then the instruction screen has its own event loop. I don't know if I like that. You know, everything has its own event loop, and the level editor has its own event loop. There's pros and cons. One of the cons was, like, you know, all these things that you have to remember, like that you shouldn't use 100% CPU. You know, you need to mitigate that. Or, you know, there's various pros and cons. And also there are bugs in Dave Newcomb that I had to work around, where if you go into the level editor and come out, then like keys will be stuck in the on state. It still thinks a key is pressed. That was pressed when you went into the level editor when you come out of it, and nonsense like that. Ideally we want, I don't know, I still think about it, but maybe we should just have one event loop that more generically somehow, depending on where you are in the game, I don't know, I'll think about it as I go along, but I'm not too worried about that right now. Okay, so if we get a quit event, in other words, if the user clicks on that thing over there, set running to false. Okay, I probably shouldn't bother to draw a frame. This is a bit weird. It still goes on and draws a frame and then it exits. But let's see if that works. Okay, just for fun, we run it. Oh, we don't have the window dressing. Yes, that's an option that we passed to create a window, I think. SDL create window takes flags, and one of the flags is surely not resizable. I don't want resize, I want maybe, unless it's creating it, but off screen. Oh, it is there. It's just off the top left of the screen. Oh, off the top of the screen. Okay. So SDL window shown. yeah, we don't want a resizable window. Now for some types of games we might want a resizable window, but not right now. Available, not found. Okay. So I press F5 and we run it, and literally it's sitting in, and this is nice. We got our core application loop going, it's polling events, and it's rendering every frame. It doesn't look like it's rendering anything different each frame, but we can prove it is. And if I press the X, we get our quit event, which sets running to false, which plonks out of the loop. There's a couple of problems with this. The first problem is, as I pointed out earlier, if we go look at our CPU usage, actually I'm not sure, I don't know if it'll use, it might not be a problem. It depends how the poll event stuff works. Let me just, what's it called? Hello, so we go to H. Yes, it's eating CPU like nothing. It's using a full core. Okay, that is obviously, it's literally just sitting there eating CPU. There's a number of ways to mitigate that. A very dumb and simple way, but that works quite well, is to just wait 1 millisecond, and that's not very elegant, but it will significantly reduce the CPU usage of the application. No, it's like much more reasonable. It's okay, it's still high, it's still too high, but we're gonna do something smarter there in a second. 100% CPU core hogging. This is a bit inelegant. Let's sort of do the job. Sort of do the job for now. Okay. So basically that waits 1 millisecond. Before each. I want to do something here just to prove that something is happening regarding the rendering. Set again down equals 0. Okay. Plus n if n. Okay, so now you can see that actually we do in fact have something happening. Every frame, I've just created this static. Just means, well, effectively a global variable with local scope. So every frame it just increases the amount of green until it reaches the maximum. This color is specified as a RGB triplet. I'm sure everybody here knows what RGB triplet is. Do I need to explain it? Yes, I don't know. Every color you specify, long story short, is to specify a color. Yeah, how do we put this right? In the typical color or video standards that most people are using today in file formats, graphics cards, JPEG, like the JPEG file format, each color is specified by that's what's called the RGB triplet. RGB meaning red, green, blue. So it combines some amount of red light, some amount of green light, some amount of blue light. So we can make this blue by doing that. Okay. And so we specify the color as some amount of red, which is in RGB a value from 0 to 255. The green is some amount from 0 to 255, and the blue is an amount from 0 to 255. So it's 3 bytes. Each byte is 0 to 255. A fourth byte can be used for transparency. So then you have RGBA, RGB alpha. So if you have transparent sprites, so if you put that N in the front, then so it's red, green, blue. If we put the N in the front, we're going to get, red window. That's pretty basic stuff. Okay. So red and blue. Then we're going to get purple. Like red and blue light combined to make purple light. Okay, this is basic stuff. Everyone knows this. Or do I need to explain it? I don't know. Yeah, I guess so. I must assume people. Yeah. So update the surface means basically in this context black buffer to frame buffer, because we do our drawing to an off-screen buffer, and then we flip the entire surface over in one go. Right. So that thing probably rendering about 200 frames a second. A really simple little now, the only thing we need to do now to make this a Hello World application is to actually write Hello World on the screen. There's a few ways we could do that. First is pixel by pixel, which is not really the right way. The SDL full rect takes the surface we're drawing a rectangle on, and a destination a rectangle, and color. The reason we need to call SDL map RGB, I'll explain in a second. The actual surface, video cards, and well, it may not even be a video card. It could be something like a VNC buffer if you're looking at some other computer remotely. But the different video modes, like depending on the graphics card and depending on the user settings and the operating system or whatever, can have different formats. Like some video cards might be representing the red, green, blue, alpha in that order, but other video cards might represent it in different order, like alpha, blue, green, red. Or another difference might be the depth, like a sort of typical high color 16.7 million color display mode has a byte for the red, a byte for the green, a byte for the blue. But video cards also typically have like 16-bit color modes, where you may have each byte, each color, each pixel is 2 bytes, and then you have like, say, 5 bits for the red value, 6 bits for the, how many bits do you have in 2 bytes? You have 16 bits, so that would be like, or is it 6 plus 7 plus 6? I mean, no, right? Yeah, 5 plus 5 plus 6, yeah, 565. That'll be a 565 format, where you have 2 bytes and 5 bits for the red, 6 bits for the green, 5 bits for the blue. No? So we need to take our RGB triplet and map that to the display format of the actual surface, the video surface we're actually working with. And the map RGB stuff does that for you. So if your display mode is in 16-bit mode, where you have, like say, if the display mode is in a 16-bit mode where you have 5 bits red, 6 bits green, 5 bits blue, then SDL map RGB will take like FF and map that into a value, a 16-bit value that is appropriate for that video surface, video mode that you're in, which will be, I don't want to work it out now, but it'll be like in binary 111100111111, and that will be like the 2 bytes. Okay. So the mapping, this mapping will take your red, green, blue value specified as byte, and map it to whatever display mode you're in, the format of the display mode you're in. So if you're in a 16-bit mode, you know, it'll map it accordingly. Or if, you know, well, yeah, that's the basic idea. So we have to call map RGB so that it sends, you know, it first has to convert the color you want into the mode of the surface you're working with. Now I just want to call another full rect to draw a simple letter, but this is really dumb. So this, I'll test something. So rect. Surely this thing is a constructor. I don't know, let's check. So the actual color is sent in a 32-bit integer. The SDL map RGB takes your red, green, blue and maps it into that 32-bit integer. So if it's a 16-bit value, it'll just use those 16 bits and ignore the rest. Okay, so we can make this black. RGB 000 is black. So FF 255,255,255 is white, and FF 0,0,0 red 0, etc. is x equals 10. Seems like we can't do that. Let's do rect at 10 and rect at height equals 80. So I'm going to draw a black rectangle on top of the background color. It's really horrible. Right, so we have a black rectangle there. Now we could use this to write some text by having a bunch of rectangles. There must be a better way. The correct way to write text, I think, there's a library, and okay, there's a number of different ways to write text. The dumb and simple way that this other tutorial is using and maybe we should use that, is to just split an image that says hello world. That the other tutorial I was copying. So in Photoshop we can just create, or even Paintbrush. So 800 by 600. No, not 800 by 600. This is Hello World tutorial, so choosing is you have to write Hello World. Yes. Can't we write something? I don't know. Whatever. Anyway, so save as. Should probably at least put some colors in there or something. I don't know. So for web, save as, copy, bitmap. World. Let's create a data folder for our game data. This, BMP, 24-bit. Right, so now what I want to do is load that image. I don't know how to do this. SDL load BMP, it looks like we can just do this, right? I don't know, let's see if this works. That is really horrible. The hard-coded path. I don't know what will happen if we just do that. That's also not pretty. I think it won't find it. SDL lit surface. So what this does, it should load. I think the path is going to be wrong, but I'll find out now. Yes, it will be. It's easy to fix though. Right. So that bitmap we just created here, saved it as a BMP file, and now I call SDL load BMP, which loads it into a SDL surface object, which allows us to work with. Okay. Then to draw that, I think we use this, and so SDL lit surface. So we first draw our rectangles and stuff, then split the image, source rectangle. Hello? Sorry, I'm hearing noises here. If you want to check if there's someone here. We need a destination rectangle to put, tell us where to put it. Does everybody understand the X, Y? X is your horizontal axis in pixels, starting at 0 and going up to, if you have an 800 by 600 window, like just x 0, 0 is in the top left of your window, and going up to 799 and 599. So we can put that, I don't know, somewhere 200 by 200. That is horrible. Do not pass a 0 for a pointer. This is, do not do this. This, I don't know who did this, but that second parameter should be a pointer. And yes, null is the same as 0, but no, do not. If it's a pointer, put there null, and there's good reasons for that. If you, anyway, it's just, yeah, I cringe if I see that. Anyway, that's off topic. Okay. I want to see if we can use this. Is there a width field? W here. So 200 pixels across, 300 pixels down, we want to draw our image. Okay, we get an annual exception, and the reason for that is the image didn't load. And the reason the image didn't load is the path issue, right, which I think we can solve by just going right-clicking here in Solution Explorer Properties, and then we go debugging. Wait, what? Properties. Working directory. Is this the right way to do this? I think so. Project directory. I don't know. This is, yeah, it'll do, I guess. There's probably nicer ways. I'm not sure if it should be double dot or double dot. Probably double dot. Let's see. Oh no, yeah. Okay. It's in the wrong place, but it says hello world. So we've achieved our objective for this tutorial. Good night. Bye. It's over. No, I'm kidding. It's not over. How long did that take? 1.5 hours. Yeah, that's not bad. Okay. It's in the wrong place. Why? And that flashing is horrible. I'm sorry. I have to stop that. Yeah. That's really. Let's just make that green again. Or blue, I mean. That'll look nicer. Yeah, okay. The advantage of that was it's animated, so we can see some things happening. Right, so now we have a Hello World application. And it's a bit messy, but why is it in the wrong place? Why is it not at 200 by 300? SDL blitz surface, source, SDL right. Something we should do, definitely. You noticed it crashed earlier. Why? Because I blindly assume that crashing is really bad. Your program should never crash. There's no good reason for a program to crash. Okay. And for something like this, if it failed to load, we should simply be checking if that thing is non-null. We don't want to crash. Rather just quietly not render and crash. Or, you know, if you critical data, rather check, yeah. You know, if image is null, then exit or whatever. But don't crash. Right, SDL. Why is it in the wrong place? Because I don't actually pass correct anyway. That's fine. That, if anybody doesn't know what that is simply basic C++ address of. So this thing takes a pointer to a rectangle. Okay, so we define fill in. We have a rectangle instance, and we need a pointer to it. So we use this address of operator. In case anyone doesn't know what that is, I don't know. Now what we're going to do is we're going to make this hello world bounce around the screen. Why? I don't know. Just for the hell of it. Because it's more fun if it's animated. So we can have an X and a Y position of this, which can start in the, well, let's start at, I don't know, it's 200 by 150, I don't know, it doesn't really matter. XY position of sprites. This is a game sprite. Okay, this hello world is a game sprite now. Really fancy. So X is the position in the horizontal axis, the Y is the position on the vertical axis. What we're going to do, we have a X-dir and a Y-dir. That's the direction, okay, that it's moving in. This is now a game sprite and it's going to be moving. Okay. So we've achieved our main objective. We've got it. We've built a hello world application. I should actually stop the screen and draw a line under it. But let me just carry on. It's very untidy though. We should also clean it up, and something should be more generic, like the width and height is hard coded. Okay. I don't know if anyone has any questions. The main thing I haven't done is use the renderer stuff, which I want to look at later. Now this is your basic. This is like your basic game loop. You know, if you want to make a game, and that took 1.5 hours. I mean, really. So in 1.5 hours, you got your basic framework in place, and now you start fleshing it out as a game, and you can add game-like logic. This is not a game, obviously, but we can easily make it a game like by saying, for example, so each update. Now I'm gonna increase this delay because we don't to 10 because we don't want overly. That's gonna be like 100 frames a second maximum. Remember, these are milliseconds. There's 1,000 milliseconds in a second. So 10 milliseconds is 1/100th of a second. Okay. So here what we're doing, we're going to say x plus equals to x-dir, y plus equal to y-dir. Right, so then we're going to draw the image at x and y. So every frame, the image is going to move. Now it goes off the screen. We need to test if the x position plus the image width x plus image width is greater than equal to the width of the window, then x-dir equals minus x-dir. Okay, remember x-dir is 1. So if it's 1, we make it -1. So if we hit the, basically, if we hit the edges of the window on each axis, swap the direction from 1 to -1 or vice versa. That should be at H5 actually. Okay, run it. Now basically it should, and it hits the side of the screen. So we have an approximately 100 frames per second game where Hello World sprite just bounces off the edges. That's slightly more exciting than okay, now we need to be able to shoot stuff. No, I don't know. Yeah, why not? You won't see 100 frames a second, you'll see like 10 frames a second maximum on the stream, because I'm streaming at 10 frames per second. So let's just recap. Okay, that's what the thing does, that's its behavior. Right, so let's just show you the code again in one, or what I can show the code. So to recap, we created a blank new project. First we downloaded LibSDL, then we unzipped it, then we created a new, in Visual Studio, a new project, a C++ project of an empty project type. Then we set up our paths. We did that under View, Properties window here. No, Property, not Pages. Property Pages or Properties? Well, I'm always confused between the two. Let me just View Property Pages. No, not Property Pages. View Properties window, which takes you here. Okay. So we clicked on Control, hold in Control and click on. We can do one at a, or you can just, I think you can just right click Microsoft.cpp.win32.user, right click Properties, and we go VC++ directories, and then we need to set up include directories and library directories. Include directories shall be defined the header files.h. Click there and say edit, and we added the downloaded, the include path of our downloaded third-party library. I put all the third-party libraries in a folder called third-party, just so that I know like all the third-party stuff. It's clean and separate. So we added include directory. We added our library directory. Okay. Then, so that, by the way, is very tricky to find. You won't remember where to find it. Again, View Properties window, and by the Solution Explorer sidebar thing, right at the bottom here, this little tab appears which you click on. Okay, to get to that. You won't easily find it. So okay. Then what we did is we go back here to Solution Explorer, and we did a couple of things. Firstly, under Linker System subsystem, we selected the Windows because we want to create a Windows application. Then under linker input, by additional dependencies, we need to specify the two. Okay, I don't know if you've ever linked DLLs, but DLLs, there are two files. There's a lib file and a DLL file. The lib file is used in the build process to link your application to the DLL. So it's just like the glue between the application and the DLL. when you build it. But the DLL itself is a library that is distributed. So you don't distribute the lib file. The lib file is only used for building, but you don't distribute it with the application. The DLL file, there's usually a lib usually has a corresponding DLL. Not always, but usually the lib has a corresponding DLL. The DLL is the file you distribute with the application. So we say here we want to link to SDL2.lib and SDL2main.lib. So we added these two, which you might not be able to read, it's very tiny. Additional dependencies under our, and we do that for both debug and release configurations. Okay. Then under VCC plus preprocessor, well, this is not necessary, but if you're creating a it's necessary if you create a cross-platform application. Then we need to specify that Win32 is defined as a preprocessor definition, and then I'm using so that my hello world can be cross-platform with these hash ifdef Win32, because a normal application needs a main function, but if you're creating a Windows application, it needs a win main function. So I use that preprocessor definition just to know if we're building a Win32, that's the name of the platform, Win32. If we're building a Win32 application, then define a win main function. And you don't need to understand right now what these are. It looks complex, but you don't actually, you can just copy and paste that, and you don't have to understand this stuff. That looks like something I wrote, I don't know. But a win main function has a certain template. It just has to have, it has to return an integer, it has to be win API type, and it has to take these 4 parameters, and it has to have that name, win main, and that's it. You don't, it's like, and that is the entry point of your Windows application. So when your Windows application runs, that's the first thing, that's where your application starts running. Any Win32 application starts running at the win main function. Okay. And all this win main function does, it's a stub that calls the main function. Now, if this were a Linux application, then this would be the entry point, and the application would start here. Now, that's also basic C++. Every application must have a main function, and it has to have a return an int. It has to be called main, just like that, and it has to take 2 parameters, those which constitute the command line arguments, which we're not using right now. But if we wanted to have command line arguments, we could fetch them there. Oh yeah, that's what these things argc and argv is the count of underline arguments and the number of command line arguments. That's not relative. You don't need to know that now. You can just ignore that. Okay. Then we call SDL init. Saying we want everything, all its functionality, audio, keyboard, everything. Then we create a window titled Hello World, starting at 32 by 32 of width and height 800 by 600. So then we load our game data, which is just, it's one simple bitmap, which we created in Photoshop, which you can create it in Paintbrush or whatever you want, or download an image. So we load data / hello world.bmp, and that is an X and Y position. Right. Then the important thing, the game update and rendering loop. So the game sits in a little loop running. The game is running, and it sits in a loop while running. And this is our event loop. So we sit in this loop while running, and we, in order to get keyboard input or mouse input, whatever, we're going to get that by calling SDL poll event. So there are keyboard events. If we want to process a key event, if what's going to happen is, if the user presses a key while the application is running, it's going to add that event to an event queue. And if you're typing or moving the mouse, all those things are added to an event queue. And poll event just retrieves those events so that your application can handle them. So you set in a loop, processing events, mouse events, whatever, keyboard events. And this inner while loop, basically, depending on the return value, like you may have multiple events, like you could have 10 key press events or 3 mouse movement events. So you want to process all of them as fast as possible in the inner loop, as many events as you have. What you don't want to do is process only one event, because if bad things start happening, like if let's say your game is limited to 100, let's say your game is limited to 20 frames a second, and someone has a mouse like a gaming mouse that's configured to throw out 200 move events per second. If you don't put this inner while loop, if you might be tempted to just say, well, it's simpler just to have one poll event. Nobody's ever going to type that fast, or whatever. These events can start piling up faster than you process them. If you're only processing one event, so you must process as much as possible. Timer events you could also have, like, if you have a timer running at 100 Hertz, you're going to have, or a high-speed mouse, these events could just pile up and pile up and pile up, and eventually your application, I don't know what will happen, but it'll probably crash or start behaving in some funny, undesirable way. Plus the input will become very laggy, like it will never keep up. Like you'll move the mouse, and like only later will there'll be this big lag, like this screen. Anyway, so you can't just poll one event. You have to poll all events that are available until there are no more events to poll off. The quit event is a special event, meaning the user clicked that. Okay, so we said running to false if the user clicks that. Right, and then now we have a sort of inner loop, which basically we get from our window. We call get window surface, so we want to draw to the surface. And that's basically where we are now, sitting in our loop with this hello world thing bouncing around at 100 frames a second. And now we want to, now it needs guns. It needs guns. Okay. You need to be able to shoot. I'm going to make this 400. Okay. This is going to be like hello world, but with guns. Okay. I'm just playing around. Just playing around. I want to make like Arkanoid, but where you have a gun almost. I want to say if we have a key event, right? And now I literally don't know how to do this, but I want to say if we press space, then we're going to shoot. SDL event. Set bash. SDL wait event. So now we need to check the event type. This basic concept of the event loop, that's basically how our Win32 application works. That's the whole Win32 model. The Win main function sits in a loop, getting events on an event queue. So what SDL is doing is hiding that for you. It internally calls. So when you call SDL poll event, it calls the Win32 functions to poll events, Windows events, and translates the Win32 events into SDL events. Okay, so what I want to do, SDL, I want to SDL key events. Okay, yeah, I think using a switch might be better than a big if else, because we can end up with a lot of these. Okay, if we have a key down event, right? So we want to check if I press. What I want to do is have a little gun at the bottom, and if you, it's very basic and simple and stupid, but yeah, that's the idea. So I want to check if you press space and then fire a little projectile at this block. I'm making this up as I go along, obviously. Okay. So so yeah, we check. So events, as I said earlier, they can be mouse events or you know, mouse movement will be just another type of event. Keyboard presses, key up, key down, you know, all that stuff. It's just events. Timers, events. Okay. So now we check if key down, then I think what we do is basically typecast this thing, the event object. Oh no, we don't even need to do that. I think we do this. If event, this is a bit horrendous. There's a lot going on in there. I'm not going to go into detail there. You don't need to understand all of it. But depending on the key, there may be different ways where you have to sell. I just want to check. It's probably going to be more or less the same as, yeah, something like this. I'm copying from Dave Newcomb now. Okay, so if we press space, right, I'm going to create a new class. Bullet. Okay, now we're going to include, let's say, vector. So create a new empty class which has an x and a y position and x there and a y there position. Okay, that's very crude. It's okay. Whatever, it'll do the job for now. So basically I'm creating a class so we can create more than one project. I want to create more than one at a time. So we can have little bullets firing as at this hello world sprite. And I want a vector because we want an array of them. Or should I keep it simple and just have one for now? Okay. Yeah, so we create a bullet class which yeah, constructed as zeros everything. I think in the new C++ you can do this. I can't remember, or something like that. I don't know. C++ 11. you just do that. Anyway, but I'm not sure. Some people watching might actually know. But anyway, class bullet. Okay, C just stands for class. Okay, constructor. The constructor, I just want to zero everything, and then I want to have a separate function called initialize, which takes in x and a y and an x there and a y there. This is just a you could put all this in the constructor if you want, and just have one function. You just have one constructor that takes the 4 parameters. You could do that. There's nothing wrong with it. I kind of conceptually like to, and I feel it's a little bit cleaner, and it helps the design in some cases, is to use the constructor only to sort of initialize the C++ class, but then to have separate initialize function to kind of logically initialize the object, like what it actually does. And I don't know if that makes sense, but then we have something like this. Okay. So now we have, I think we are going to have a vector. So right, we're going to include vector, so we can have an array of bullets. Okay. So created a bullet class. So here we're going to create an standard vector of bullets, and they're not even pointers. How basic is that? Array of bullets. Array. I like to use A for array. Anyway, it's just my naming convention. You don't have to follow it. Standard vector bullets. And normally I would use pointers here. You know, you'd almost always use pointers, but for the simplicity, I'm just going to create object instances. Is there anything bad about that? No, it's okay. So basically, if you press space, we're going to create a new bullet, initialize, and I'm going to use the expedition agent divided by 4 for now. Divided by 2, halfway. That's the center of the screen. And y I'm going to use 600 minus 1. The x direction I'm going to say minus 1, and the y direction I'm going to say 0. Other way around. What does that mean? It's going to start in the horizontally in the center. I'll show you now what I mean. You'll see what I mean once I start. So if press space shoot. Okay. So create a bullet. It's just going to fire straight up. So for now I'm not using the X direction. No worries. Okay. Later we can use it. Or something. Okay. This is not very efficient either. This is not very efficient, but it doesn't matter. Okay. So basically, if I press space, it's going to create bullets. Right. We don't see them yet. Now, two things need to happen. We need an update loop for the bullets, and we need to draw the bullets. Okay. So we have a vector of bullets, and our draw loop can draw all the bullets. Okay. And how are they going to look? Just a small little rectangle on the screen. Okay. Draw bullets. Now, why did I copy and paste that? Because I want to do this. And I'm using a const iterator. Okay. a few points here. So we want to iterate over all the bullets. Start at bullets.begin. Through a for loop that iterates over the bullets, we're going to draw them all. Const iterator, you just use a const iterator if you're not going to change anything in the values that you do referencing with the iterator. So because we're just drawing them, we're not changing them. They don't get changed during the draw. So we use a const iterator. Okay, and then this iter plus iter, it's long story short, it's slightly more efficient, slightly faster to say plus iter. In cases where the order doesn't matter. Anyway, right. So we're gonna make a rectangle at the bullet's XY position, a small one, just a couple of pixels across. Big bullet. So wait. What I'm gonna do is make a const reference to the dereference star iter, the dereference iterator to get to the bullet. And a const reference is just for convenience and efficiency. We don't want to make a copy, but it's okay. Oh, we can't access those because they're protected. I'm going to just make them public for now. But gross, but it's just a hello world. Yeah, bullet. We make the width and height 5 of 5. No, 4 of 4. And start at -2, -2. And the color will be, I don't know, gray. No, let's make it. It doesn't matter. So we're going to draw little rectangles. Now you'll see if I press space, what's happening is, and it worked correctly, it's created a little dot over there. So, and it's not moving because we don't yet update the bullet. So as I pressed space, it initialized a bullet at 800 divided by 2 across, 400 pixels across, and 600 minus 1 on the y-axis, 599 position, and added it to the array of bullets. So we can add a few, and they're all there, but they're all drawing on top of each other. Okay. Now in our loop, it draws the bullets at their position as these little dots. Right. Now, and this is the core of a game. You have a update loop and a draw after that. Once everything's updated, you can draw everything. So ideally, actually, right, we should conceptually separate the updating from the drawing. Okay, so here we're going to have game draw. And here we have game update / tick / heartbeat. So we update all the objects in the world. So we do all the game logic and update everything, and then we draw the game frame after that. Oops. Oh yeah, here we go. So sprite update, and that's our hello world sprite. Movement. Bullet movement. Okay. So for the bullets, so now we can also iterate over them, but I think we don't want a const iterator because we might want to change things. Actually, I'm not sure if it can be const. I don't know. But okay, what we should do here is have an update function, which later we can make virtual to make things interesting. So every update, this bullet is going to have each bullet is going to have update called. And that very simply determines direction. Okay, it's going to move the bullet one little tick. Okay, add to the x position, the x direction, which is 0, because it's just moving vertically, and subtract 1 from the y direction. We're going to need to have some logic to see when it goes off the edge of the screen and stuff like that, so that they don't pile up forever. But draw bullets. There we have bullet.update. And we can't use a const here because it's update. Okay, update the bullets. Can I convert this from const bullet to C bullet? Yeah, we don't want to. That's because we have a const iterator. Comp const because the object changes in the update. And now, if I press space, the bullet fires. There we go, shooting. Okay. Right. Okay. There's no collision detection, so nothing interesting happens. Let's see if we can fire a bunch of these things. Okay. Now later what we can do is like maybe add. So now, you know, this is starting to look almost like a little game, a simple game. I mean, we can almost make a game out of it. It's only taken a couple of hours. I mean, it really, yeah. Okay. Let me not exaggerate. This is not. I mean, you can't exactly sell this and make money and say, hey, I made an awesome game. But the point is, so we have bullets that move. Now all we need to do, okay, is if this is 0, check. Now we want to do check if bullets went off screen. That is a bit unfriendly to read, so I'm just going to do this to make it more readable. Now what are we going to do if the bullet goes off screen? And I'm going to make this, I'm just going to make it disappear halfway through the screen just to test MY less than 300, just so I can see it's actually disappearing. bullets.erase. And I don't know if you can do this safely in the middle of the update loop. I'm going to find out now. I think so. Erase, I think that's the point. Erase, iter. I'm not 100% sure that logic, but the idea is it's going to reach a point midway, and then, yeah, no, we can't do that. Vector iterator not. I should know this. This is basic stuff, but I don't. Why is this happening? Because we deleted the thing while we're looping over it. But that shouldn't be a problem. To erase. Iterator, position iterator goes last. Oh, we need to do something. I think we need to do something. Yeah, we need to an iterator pointing to the new location. It returns an iterator pointing to the new location of the element that followed the last element raised by the. So we need to do this. Iter equals. Yeah, maybe let's start erase iter. Now when they get halfway, they should start disappearing. Okay. No, I don't know. Okay. Check if bullet collided with hello world sprite. Now it'll be something like this, but more like. And we need to change these to ends. And that, by the way, should be 0. Okay. Equal to y, and it's less than equal to x plus image. This is horrible, anyway. Image y is less than equal to y plus image. Does everybody understand that? Basically, I'm checking if the bullet is within the bounds of that hello world sprite. Then we have a collision. Bullet shoots hello world. And again, we want to delete the bullet, but we also want to do something like, I don't know what, something should happen. The thing should disappear or something. We just reset its position to 0, 0. Okay, boom. Interesting. Why is it like sticking? Why the thing? Something is wrong with that logic. Read the external y direction. If x plus image width is greater than equal to 100, or x less than equal to 0, not sure why that isn't working out. Yes, nor do I understand why I'm getting an error here. Boom. Okay. Now we should get points. Looks right. I don't know why it's Basic stuff. Why am I getting the problem here? So when I remove the first one, it was fine, but when I remove what, the last one? I don't know. What? Vector iterator not incrementable. I don't know. Maybe I should Google this. Vector iterator not. Why, this is basic stuff, man. That's what I'm doing, so what's the problem? Oh, we don't need to plus it because we've already plussed it. So if you delete the last one, right, but then how am I supposed to fix this? I'm just supposed to. Because it was normally the current one. So when we do this, we don't want to do that. I think that's what's going wrong. So I could use a while loop. I think, can we? Coming up to this. Okay. Alter, not able to. Inserting that, I do that, right? Else plus it. It calls continue, so that's probably overkill, but I don't know if that's, I don't know if that makes sense because I'm getting very tired. Okay. This is the best game ever created. It's gonna be a smash hit. Right, I think it's now 2, so I'm just deciding what to do next. So we got a hello world with guns, with a gun, and so this, I mean, our whole design is a bit, I mean, yeah, it's too many hard-coded things. That, the window width and height, window width, screen width, it's not nice to hard code things. Screen W, I'm not mad about that name, but window width, surface width, and window width, screen width. I normally use uppercase for constants, things that don't change. Now these don't change, but they could change. Like if you added functionality to change the size of the window from the game without restarting it, then I guess they could change. I don't know. Obviously it would be faster if I consts, but yeah, that's a pretty minor point. I mean, it's not something I would lose sleep over. So we're going to put the screen width, screen height -1. It can be screen height -100. Okay. So I'm just making the width and the height less hard-coded and more configurable. And screen width, screen height. So basically anywhere where 800 plus 600 had occurred. Let's make these bullets bigger as well. These tiny little rectangle bullets. And faster. When we create a bullet, let's give it an X direction of. So when we press space, let's give it a Y direction of -2, so we make the bullet a bit faster. There we go. That feels better. That's very silly. Okay. Now it should be easy to make that bigger, or like say 1024 by 768. Yeah. So now we have a higher resolution hello world with the gun. Okay. And I mean, we could the whole update should probably be in like a function, and the draw should probably be a function call, you know, just to wrap it up. And then I think we need to call this first surface. Something like that, or SDL, load free surface. So it's always a good idea to clean up properly after yourself, whatever you create on exit. So yeah, that's you know, that's it really. You can now create I mean, if you follow this, you should be able to create a simple hello world application. Okay, it's become quite complex, but using LibSDL, and you got the core, you know, this sort of kernel of a game in there that it doesn't run in release mode, but I know why. I think it's a path again, I guess. And properties, debugging, working directory, double dot. Shouldn't hang though. Anyway, for now it works in release mode. Hey, later we can add sound and audio and that stuff. But I don't know what to do with this now. I want to use the basis and just, I don't know, I want to make a new game or start something new. I don't know, 3D? Maybe it could be something 3D. 2D puzzle game. I don't know. Anyway, this is a start. Right, that's I'm gonna call it a stream because I'm tired. So I mean, it's a start. Obviously, it's not like it's not going to win any awards, but you literally follow what I do. You can have something, same thing up and running. I should probably, yeah. I'm not sure what I want to do with the source code yet, so I might upload it some way. Anyway. I hope this is useful to someone. Yeah, I literally did this from scratch, too. You know, there's nothing special I did yet. You can literally do exactly what I did. The tricky part, if you follow this now, are going to be, I already know what sort of things are going to be tricky. One is you're not going to know where to set the include include directories, like view, unless you listen closely. Property page, not, you know, things like that. View property pages. I mean, view properties window, sorry, and then down here. You know, that's one of the potential sticking points. Right click properties, EC++ directories, and then the directory for the header, directory for the lib files. Then the other thing when you run its application the first time is it's not going to find the DLLs, the SDL, DLL, and that's very straightforward. You go grab the folder with the DLLs, and then you go to the Solution Explorer, Properties, again, you go debugging, and there's two things you set up in debugging. The working directory, one parent up from the default, so that it finds the bitmap files and stuff. And to find the DLLs, you do this. You set your environment here, path equals, and then you enter the DLL path, semicolon, percentage path, semicolon, so that it finds the SDL, DLL when it runs the generated application. I think those are probably the most tricky bits. And of course you must actually include SDL.h. And yeah, right click properties. When you start also you set the subsystem to Windows, and you have to create this win main function. You don't have to understand what these things do. Again, you just have to create a win main function that looks exactly like this, but you don't have to understand any of it. You know, it just has to be there. That's the entry point of your application. And then it calls main, and I think those brackets being in line like that. So I followed loosely two other people's tutorials, and I didn't even read them before I started the stream. I literally just followed it during the stream. So this lazy foo, so these are useful links, and the other useful link is, but I didn't follow this exactly, but this is also useful. That's useful. And I'll probably in future, I have a feeling I'm going to need to create renderers. I'm not sure yet, but I have a feeling that to do more interesting, fancier games, we'll probably need to work with renderers. But that's, yeah, yeah, that's about it. Anyway, yeah, and cool, alright. Is like near 20 to 3 in the morning, so tired.